flipped classroom lesson for section 9.1 on the confidence interval for a mean. So the resources you need are the PDF, which is on the web page, the Khan Academy link, which will be posted. You want to watch Sal Khan's video about confidence intervals for a mean. And what you want to try and do is contrast this with Chapter 8. So in Chapter 8, Section 8.1 was the confidence interval for proportion. So what we're doing is saying, okay, instead of a proportion, we're talking about a mean. In 8.1, what did we do? Well, we had P, the actual proportion, add or subtract our Z asterisk, which means we don't know what the Z-score is. It depends on what confidence interval we pick. So our Z value times the value of the standard deviation. In 9.1, instead of a proportion, we've got a mean. So instead of a Z-score, we have a T-score. So what happened is the standard normal curve underwent a scale change so that we have the T distribution. At the end of, you have a table for that. It's read the same way as the Z-scores. If we're reading those tables in the back, if we're looking for a proportion, a percentage, then we're using the Z values. If we're looking for a mean, we're using the T values. Now, you really would use Z for both if and only if you knew the population spread, and that's very rare that you would know that. So when in doubt, when you see mean, use T-scores. So we need to talk about the conditions. So the conditions, if we have a simple random sample, if we're doing an observation, random assignment, if you're doing an experiment. Second condition, the distribution of the population has to be approximately normal. And the third condition for the template is the population has to be greater than or equal to 10 times the sample size. The margin of error is, right here, it's what's being added and subtracted from the mean. So it's 1/2 the width of the confidence interval. And what's going to happen is you're going to do these 3 questions, 4, 5, and 7. You're going to pause the video as you're doing those. But we want to call your attention to this question first. Here's the standardized question that goes with this section. So this is at the end of Chapter 9, AP Question 3. Here's the question, which is going to be easier for you to read it from your textbook. There are the options. Only one of these answers is correct. Read the question, give some thought to it, and then we'll go over the answer at the end of the lesson. So before we get to, we also have to deal with degrees of freedom. In order to read the T table, and we'll clarify this in class, but in order to read the T table, we have to talk about degrees of freedom. It's going to be 1 less than the sample size. So this is going to be introduced to you in terms of the T distribution, because really what you have is you have multiple scale changes to the standard normal curve, and they all depend on degrees of freedom. And so you, instead of visually worrying about having picturing all these different T distributions, you're just going to say, okay, I calculate whatever the sample size is, take away 1, that's how many degrees of freedom I have, and that affects the specific scale change in the standard normal curve that's going to generate the T values that we need to answer the problems. Okay? So you're going to go to P4, P5, and P7, and then resume the video after you've done one of those at a time, or all 3, whatever works for you. Okay, P4 asks for a 95% confidence interval for the concentration of this toxin. So we put the values in our list, and we went to stat test 8. And what we're doing, we're inputting an actual data. So we have an option here. We have all the data. We have the raw data. It's in list 1. Our confidence interval, we have to identify it, is 0.95. And the calculator will generate the t interval. So the t is telling us that it's an interval regarding means. There's the interval. The mean is halfway between the two of them. There's your spread. There's the number of data points. So if I said, okay, if I take the average, the sum of these two, divide by 2, that's the center. If I subtract the right-hand endpoint, take away the center, that gives me the width of the confidence interval. They also asked, well, instead of doing that, if we just do this, if I suppose I do, you get the same answer by doing this. The inverse t, if I know I want to capture 95%, since the curve counts from left to right, I have to go to 97.5%, comma, the input's calling for 9 degrees of freedom, that's my t-score. So now what am I saying? My standard deviation, which is stored here when I ran the test. So this value is stored until you rerun another test, divided by root n. That's your standard deviation under the size change for the sample size 10, times the specific t-value is giving you the width of the interval. This is the value that I'm adding or subtracting from the mean. Okay? So this 79/100ths right here is the same value. We could get it that way. Now P5 is different in that for P5 they gave you the statistics. They didn't give you the raw data. So they told you, here's what happened. I was given this mean, that standard deviation, and that sample size, and I want a 95% confidence interval. Here's what the calculator spits out. You're 95% confident that the true mean is between these two endpoints. There's the measure of spread. That's your n. So in the dead center of these two is 98 and 1/10, and the width of the confidence interval is 262/100ths. So I'm adding half of that and subtracting half of that from 98 and 1/10. So if I say, well, under the circumstances, what are we doing here? You're 95% confident that the true mean is in here. The question is, what about 98.6? Well, 98.6, what you assume to be your average temperature, is outside of the confidence interval. So under the circumstances, you're going to reject the null that this is true, that the true mean is 98.6. It's not in your confidence interval. And then the last question, be careful how you interpret this for the multiple choice. The correct answer is D. This is not, if you go back to 8.1, it's not a 95% probability. It's 95% confident that the mean level is in that interval. The solution to the standardized test question is C. If you compare these two, that's what the scale change does to the standard normal curve. It makes the measure of spread larger. So when you get to class, We're going to go over these. You're going to work collaboratively on the 9-1 problems, and we'll go from there.